and we're done. And that was pretty nice. So we've already done the first problem, and that worked out nicely because everything was already set up for us. Now let's take a look at the second problem. This one is not set up for us. We don't have two numbers in front of the variables already where they're the same number, but one's positive and one's negative. So I need to make that happen. Well, you need to figure out if you want to do this to the x's or the y's. I tend to always go with the x's because they're just out there first, but you don't have to. So if I do that, I'm going to look at the 2x that's coming first on the first equation, and I'm going to look at the 3x in the second one and say, what number can I turn the 2x and the 3x both into? And that's going to be a 6x. It's kind of like finding a common denominator. So how do I turn, let's start out with the first equation into having a 6 out in front. Well, to get that 2x to turn into a 6x, I'd need to take that entire equation and multiply the whole thing through by a 3. So let's do that. So multiplying that whole equation straight on through by a 3 would give us a 6x, a positive 9y, and 3 times 19 gives us 57. Now, I need to do the same thing to the second equation, but remember, I need one equation to have the positive 6x, and I need the other equation to have a negative 6x so that when I add them, they eliminate. So to get the 3x to turn into what I want, a negative 6x, I actually have to multiply the whole thing through by a negative 2. So if I multiply the whole thing through by a negative 2, that will turn my 3x into a negative 6x. It will turn my negative 7y, though, into a positive 14y because I'm multiplying by a negative 2. And don't forget your other side. The negative 6 times the negative 2 gives me a positive 12 on the other side. Remember, I'm doing this so that I can eliminate. So when I add, a variable should eliminate. The 6x added to the negative 6x do cancel out and eliminate. That's what we wanted. Then I just need to add everything else normally. So the 9y, the positive 9y added to the 14y gives me a total of 23y. And on the next one, on the other side, let's see what we have. We have a 57 plus a 12, which will give me, let's see, 69. Keep on going like you would a normal equation because this is looking pretty nice now as I can divide both sides by a 23, which gives me a final answer for just my y anyways of 3. Remember though, my answer needs to be a point. I've got part of my point. I've got the y coordinate, which always comes second. So I need to take my answer from my y and go find the x. I can do this by plugging this into any version of the equation. I always tend to plug it into the first equations. That way I don't have to worry about whether or not I've made a mistake. Pick whichever one's easiest. I'm going to pick the top one just because it has no negatives. Make your life as easy as possible. You have the option. So we've got a 2x plus 3y equals 19, and we're going to replace that y with a 3. Again, don't forget your parentheses when you make the swap. So what this means is now I have a 2x plus, I've got a 3 times 3, which is 9, equals my 19. Keep on solving it like you would a normal equation. By subtracting your 9 from both sides, that gets us a 2x, because these will cancel out, equals 10. Last step here, divide both sides by 2, and that gets you that x equals 5. So now I need to take my 5 and just put it back into my final answer, my point, where the x's should go, which is always the first part. So our final answer for this one is the point 5, 3. So our two lines will intersect at the point 5. Continue.